Good day, good people. Welcome to JJ Tech Tutoring. Good day, engineers. Um, we are going to be solving the short transmission line today. And if you haven't checked Pi model and T model, I've already uploaded them that are under medium transmission line, guys. So one thing I like when I'm solving problems, electrical problems and math problems, I love to go for a very difficult one before a simple one. I don't know, but that's how I cope and that's how I manage to understand concepts. When I go for a very bigger stuff, then I am able to come back and just tackle the smaller one because in most cases you are taught smaller things so that you can go step by step. But at the same time, smaller things are very confusing. Right? You will see here how we're gonna do here. It's gonna be totally different from how we are going to do how we did pi and t. But at the same time, this one was the first step, right? But it is not having that much relationship, right? But anyways, they are big academicians. They know what they are doing when they want us to start from small. But in most cases, when I start by a bigger number or a very difficult circuit, then to smaller circuit, it's easy, right? But when I start with a smaller circuit, I get confused when I get to the bigger circuit because it's totally different. I don't know. I don't want to philosophize this. Let us start working, right? So in shorter transmission line, as you can see, guys, there are not any divisions, there are no nodes. So it's just a mesh analysis, right? So here you can see IS is equals to IR, right? Sending current is equals to receiving current. You can see clearly, right? There is no anything that is stopping them, right? There are no node, there is nothing. So IS is equals to IR. So as you can see here, we don't have a live current because a live capacitor because live capacitor is 0 to this, right? Now, let us start solving now, right? So actually we have our Vs here, right? So Vs is equals to voltage across this resistor plus voltage across this inductor plus this VR, right? So we're gonna have the voltage across this resistor is ISR plus ISXR, right? Then plus VR. Makes sense? Makes sense. Makes sense, right? Now, as you can see, we have R here and we have XL here. What are those? What are those? If you have been doing electrical engineering, then you understand that those are impedance. This is an impedance. Vs is equals to Is factor out so that you can see it properly. We must not be in a rush, right? So what is this? This is our impedance, right? So Is multiplied by Z plus VR, right? Plus VR. So this is our impedance, right? So it's ISZ, right? ISZ, right? So this is our first equation, right? So let us go and look for Is. Let us go and look for Is. Our Is is equals to IR, right? So we have to take this and substitute it where? Here, right? Then it's gonna be IR Z plus VR, right? And we know very well that that concept or this under these transmission lines, we are only going to be looking for A, B, C, D parameters, right? Now we're gonna have to say Vs is equals to A VR plus B IR, then Is is equals to IR. So that means it's D, right? Or you can write it properly. Is equals to CVR plus DIR. So why did I say Is is equals to DR in this one? It's because our C is 0 this side and we only have Is is equals to DIR, right? So what are we going to do now? Let us write them in full, right? Let us write the equation. The equation that we have now is Vs is equals to VR plus ZIR. Then Is equals to 0 VR plus IR, right? So that means A is equals to 1, B is equals to Z, C is equals to 0, D is equals to 1. Makes sense? Make a lot of sense. All right, so this is it, guys. This is our short transmission line, and this is how we solve it. This is how we solve it. So don't forget to subscribe, like, and share. The shortest word, the shortest way to know it. This is how you should know it. Good luck.